I am currently in the Berkshires. No identifying characteristics. There's that. We're walking away from things here and heading up this hill. And already we start to see, if I just look around, you can see there are clouds building. Earlier today, it was just a blue sky. And while we're looking to the east, generally east, northeast, that direction, and looking to the west in this direction, what do we see? There's no sunlight right now because the clouds are covering. When there is sunlight, you'll see, and it gives you an idea of where this is going. I just wanted you to have a look. I got a spot where I could really look west, and I see more constant clouds and not so much farther away, but also there's a little bit of sunlight. There's still a spot in between clouds where we're getting a lot of sunlight. So it's not there yet. We still have time, probably a few hours before severe hits. But being that it's a warning doesn't mean necessarily that it's going to be here, but it gives you a pretty good idea that something is on its way. So not that I'm getting to any peak of a mountain here, I'm actually looking for a better view to the west. All of these clouds indicate to me one thing, that they're cumulonimbus or parts of that, and the dark spot in these clouds is water formation. And in fact, if we were to look at those really closely, I'm going to take a photograph of one of these really up close as I can get in with my telephoto on my phone, that you'll see water movement within the cloud as strands coming out of part of it. That is a stacked cloud, and it's not stacked tremendously high, but it is stacked. It's not a thunderhead yet because it hasn't built itself into one. They're the beginnings of what could eventually become thunderheads as they collect moisture and as they condense and pick up more content. So in the afternoon, later afternoon, it's early still. They need time and they need to gather more steam, as it were, to become thunderheads. Those don't have enough density and friction. It is quite tall already, and you can see if I blow this up just a little bit, you can kind of see that gray into it, which is an indication that it's not just a fluffy little bit of moisture in the air. It's quite thick and dense, and it is accumulating. And thunderstorms are typically a convection. So from down low to up high, this is why they stack up and why they get tall, is down low it's cool or cooled. It's usually, but what happens is it's warm down low. It's getting warmth from the surface below, heat from the earth. And you've got up high, there's a little bit of moisture, and there's actually a lot of moisture, and there's a lot of difference. And when it moves along, it picks up moisture as it comes, and it gathers steam or mist. It comes up into it. It pulls it up, actually, draws itself by positive or negative energy. I'm not sure which. And it's what makes a thunderhead. Now looking up at this one, it's got some potential to it. I'm going to take a couple snapshots and show the moisture in it and maybe even ice. I see a couple things that I'm looking at in the cloud on the right side. It's sort of an edge that looks white and has rays coming out of it. I don't know if that can be seen on the video if you blow it up or not, but I'll get a closer look in a moment with a couple snapshots pointing to what I'm seeing as an indicator. So as it gathers moisture and goes along the land and so on, it gets heated from underneath and hot air goes up. And when the moisture in it gets high enough to cool down and drop out, it cools down and drops. And then it goes As it goes down, it catches the updraft and goes up again. Sometimes on its way up, if it's stacked up really, really tall and it's high, it'll freeze on the way up, and it'll freeze into an ice pellet. And sometimes, depending on the temperature and the stack and how tall it is, it won't. So every thunderhead has a potential for freezing and rain, depending on how tall it is. In a short one, of course, it'll just be rain. And sometimes it just doesn't. It creates friction, and somewhere along on the underside of it, you have more positive and negative, and therefore lightning, static electricity, and that disperses it, but it also helps it build more of what it needs to be a really good rainstorm or a thunderstorm or whatnot. And thunder just being the sound. There is no thunder without lightning, and there is no lightning without clouds and the other parts that are there also. It's just that usually, and this is a myth, that thunder happens regardless of the rest of it. Well, the thunder happens because it's so loud and our atmosphere reverberates that sound. And there also is no such thing as heat lightning that doesn't make a sound. If you saw lightning somewhere underneath that, far, far away, it made a sound. You didn't hear it because there are so many things between it and you. There could be hundreds of miles. You're never going to hear it. If you had instrumentation that was where that lightning is, then you'd hear something different. This is what you see as, you can't see bolts even sometimes of what is called heat lightning. It doesn't exist. Heat lightning doesn't exist. I mean, every type of lightning, every type of thunder is related to heat, but it's also related to moisture, friction, positive and negative energy, and the dissipation of that energy as that static electricity comes in contact with something it can ground on. And you've got a tremendous amount of positive energy and negative energy in a cloud moving along, and until it makes its contact with the ground, positive or negative, and makes that contact point both up and down it, and lightning we think of as striking down. What's happening actually is the bolt happens in an instant. It goes up and down at the same time, which is why sometimes that is so big and powerful that it creates a fireball. The fireball is actually not something out of specific storms or whatnot. The fireball, or the ball of light that you see in a lightning storm, is that contact point of intense amounts of positive and negative electricity, static energy. When they meet, they clash. They actually clash so fast, it creates a ball of fire. In smaller storms where that friction is dissipated more quickly, you don't actually see that contact point. All you see is a bolt of lightning. If you were to photograph it at high speed, really, really high speed, something that cameras on phones are just not capable of, you would see that there is a bulge where it makes contact, where those two bolts make contact. You would see, if you looked along the whole length of the lightning bolt that you photographed or whatnot, you'd see that it does make a bulge. That's because it's out of control and it's trying to equalize, and it can't. My point is, with all of this, that seeing an oncoming storm is all wonderful, and knowing the dynamics of how that works has more to do with being out there, studying it carefully, and recognizing that we're all part of it in the bigger picture. So while the clouds are increasing and we're getting a little bit of sunlight here and there, our area does continue to have, that is in the Pioneer Valley of Western Massachusetts, does have a storm probability this afternoon. It's just a few hours away. And judging on the way that this cloud right here is sitting in the sky, indicates that there's a fair bit of moisture, and that given 2 hours, that may become a thunderhead.